Hey guys, this is Eddie. Welcome to another vectors lesson. Hopefully you guys have been understanding everything that I've been talking about. Now we're going to start getting more complicated, and we're going to introduce you guys to the dot products. So what is the dot product? Firstly, it comes from one vector multiplied by another vector. So this is a bit different to multiplying a vector by a scalar quantity. So for example, if you remember, we did, if this was vector u and this is vector 3u, that's not what this is. This is a vector multiplied by another vector. So for example, vector u times by vector v or something like that. Okay, so it comes from one vector multiplied by another vector, and another thing is the result is a scalar quantity. Okay, so when people talk about the dot product, it means that one vector multiplied by another vector, and the result is actually a scalar quantity. Now there's another type of vector multiplication called the cross product, which we're going to talk about at a later time. So let's go more into the dot product. Now if you remember, last lesson we talked about the scalar resolute. So if you don't remember that, have a look at our previous lesson, lesson number 14. So basically last lesson we said that if we have two vectors, if we have vector p and vector q, okay, then the scalar resolute of p on q means how much of vector p is acting in the direction of q. So what you would do is you would draw a line that is perpendicular. Sorry, not an arrow. Let's get rid of the arrow. You would draw a straight line that is perpendicular to q. So this looks like it's about perpendicular, and so essentially you're creating a triangle, a right angle triangle, using vector p as the hypotenuse, and this distance here, this amount here, is the amount of vector p that is acting in the direction of q. Okay, and that distance is called the scalar resolute of p on q. So the dot product is defined as the scalar resolute of p on q, the scalar resolute of p on q multiplied by the magnitude of q. Okay, the magnitude of q. So we got this length, whatever that length is. Let's call this O to A. So it's length OA. Oops. The length of OA times by the length of Q. And that's called the dot product. Okay, so let's write it out in a better way. So the dot product is written as the dot product of P and Q is equal to P dot Q. So that's how you write it, that's the symbol for it. And it's equal to this distance here, so from here to here, which is also equal to, if I give you an angle here, theta, okay, so cosine theta equals OA over P. Okay, so if I rearrange that equation, then the distance OA is equal to the distance of P times cos theta, right? Because that's the adjacent side, that's the hypotenuse. So cos theta equals A over H, if you remember basic trig. So I'm substituting the length of this side into here and the hypotenuse into there, and then I rearrange it to make OA the subject, and then because OA, the dot product is equal to the length of OA times the magnitude of Q, I'm going to substitute this where OA is, so it's P, the magnitude of P times cos theta times magnitude of Q. So this is often rewritten as, since multiplication is commutative, meaning that you can swap around. So for example, A times B is B times A. That works with normal numbers, and these are all scalar numbers. So I'm going to change it to P Q cos theta. PQ cos theta. So that is the dot product of P and Q. So when people say what is P vector P dot vector Q, then that's your answer. Okay, so let's try and find the dot product of two vectors. It's quite simple. So have a go at this question here. I have two vectors, vector A and vector B. The length of vector A is 5 units. The length or the magnitude of vector B is 7 units. Find vector A dot vector B. Okay, have a go at it, come back when you're done. Okay, so A dot B is equal to magnitude of A times magnitude of B times cos theta, and the answer is 5 times 7 times cos 70, and the answer is 11.97. And remember, this is a scalar quantity, it's not a vector. Okay, thanks for watching guys, see you next time.